Ladies and gentlemen, good afternoon, and welcome to the second webinar of a two-part series on the TSI revision package. I'm Cyril Martin, Communication Officer, and I'm very happy to be your moderator once again. As you already know, the first part on the 15th of June was dedicated to rolling stock and CCS. The recording of that webinar is available on our website. In this second session, we will focus on fixed installations and operation. And as we did the last time, we will dedicate a significant amount of time to Q&As. And as we did the last time, we may run a little bit longer than initially planned, up until 1:30, not more, so we have time to reply to the greatest number of questions possible. Last and not least, to ensure a focused and productive discussion, we kindly request that you limit your questions to the specific themes and topics covered in this webinar. So today, I have the pleasure of welcoming Antoine Defossé, Pedro Mestre, Gaetano Imperato, Esteban Coito González, all being project officers within the rolling stock and fixed installations unit at ERA, and Roberto Mele, project officer within the safety and operations unit at ERA. Thank you, dear colleagues, for being here today. Due to a scheduling constraint, Joseph Doppelbauer, the executive director of the agency, cannot be with us today. Before giving the floor to Antoine, I would like to remind you that this event is being recorded and will be available on our website in the coming hours. And so will be the slides of the webinar's presentation. Without further ado, I now hand over to Antoine Defossé.
Thank you, Cyril, and good afternoon, ladies and gentlemen. So today I will make you a presentation on the codification on combined transport, but before that, I would like to recall the situation with the TSI railway package, which was adopted by the Railway Interoperability and Safety Committee in March. We are still waiting for publication. If you're interested to have more details about the TSIs that were revised, the texts that were adopted, I invite you to have a look at the first part of the webinar where all this was explained, so we will not come back on that today. So today we will discuss about combined transport. So what is combined transport? Basically for us, railway people, combined transport is a transport of intermodal loading units on wagons. Intermodal loading units being semi-trailers, containers, swap body, roller units. So all these things that can be used also on trucks or used for maritime transport. What is the issue with combined transport? So as you see on the picture here, loading a container or loading a semi-trailer on a wagon is fine. It's something that can be done. There are standards about the way to secure the loading. But the problem comes that when you want to operate, because the combined transport, the loaded wagon will exceed the reference profile of the line, and then you can start the wonderful animation that you started. Voila. Okay, so you see the problem is a problem of gauge. In fact, the loaded wagon will exceed the reference profile of the line. By chance, you can go to the next one, maybe. By chance, the structure gauge of the line is bigger than the reference profile. The reference profile is just a virtual limit, so it can be exceeded without risk for the obstacles. Let's say the physical location of obstacle is beyond the reference profile, but there is a rule. The rule is the rule, and the rule is that when you exceed the reference profile, the transport needs to be operated as an exceptional transport or exceptional consignment. To obtain a pass for exceptional transport is a long, painful exercise. So it means that generally the operation of combined transport train is something that is not easy. It takes time, it's painful, and so we have to find a way. We were tasked by the Commission to find a way to facilitate the operation of combined transport train. And for that, there needs to be another codification system that is coming on top of the gauging, let's say. And this codification system will be presented in the next slide. Thank you. So the codification system exists already. It is defined in a document from UIC, which is the IRS 50596-6. And this codification system covers all the elements involved in combined transport. And first of all, it involved the intermodal loading unit. So the intermodal loading unit is attributed a code. This code contains one letter which is describing the type of intermodal loading unit. So it's P for semi-trailers, it's C for swap body. So this letter identifies the type of intermodal loading unit, and there are 2 or 3 digits which represent the geometrical characteristics of this loading unit, basically the width and the height of the loading unit. So this is the first item that is codified, the ILU. The second item to codify is the wagon. The codification of the wagon is a little bit more complex because there it's not just based on the characteristics of the wagon itself. It's based on the comparison of the characteristics of the wagon with the characteristics of the reference wagon. So here again on the wagon, we find first one letter corresponding to the type of ILU that the wagon can carry. Sorry. So it's a P here in the example, or a C, meaning that this wagon can carry semi-trailers and swap bodies. And there are what we call correction digits that correspond to the difference of characteristics between the wagon and the reference wagon. So these correction digits can be positive if the wagon has better characteristics than the reference wagon, or negative if the wagon has worse characteristics than the reference wagon. So this is the second item. The third item is infrastructure. Here, the line can be categorized also for the transport of intermodal loading unit by using the same code. So first one letter, P for semi-trailer. So on the line, you can know if the line is codified with a P, that semi-trailers can be operated on that line. And then you have 2 or 3 digits again, which correspond to the operation of intermodal loading unit on a reference wagon. So finally, on the basis of these 3 codes of the ILU, of the wagon, and of the line, you can, from an operation perspective, determine that if it's possible to operate an ILU on that line, to operate a train with ILUs on that line. If the combination of the code of the ILU plus the wagon is lower than the code of the infrastructure, the transport is possible. If it is higher, the transport is not possible. So what we did in the next revision of the TSI, this is described on the next slide. So we have taken all inputs available. So first we have taken the UIC IRS 50596-6, which I mentioned already, which is really the document describing this codification for the 3 elements of the combined transport. We have taken also a report that we published in 2018 about proposal containing some proposals to facilitate combined transport. We have taken also some reports, in particular a report produced by UIC and UIRR from a project called the Cactus project. We have created a working group specifically dedicated to the facilitation of combined transport. And this working group has produced some significant contribution because we have amended the TSI wagon, the TSI infrastructure, and the TSI OPE. So in the TSI wagon, there are now requirements on the securing of the load and also requirements to attribute the letter of the code before the authorization of the wagon, and to attribute also, when requested by the applicant, the correction digit before the authorization. In the infrastructure, we have made references to the codification system, references that are complemented in the Register of Infrastructure by the requirement for infrastructure managers to codify the line. In the OPE TSI, we have added requirements about the type of operation resulting from the comparison between the loaded wagon and the line. And in particular, we have specified that when the code of the loaded wagon is lower than the code of the line, there should not be any more exceptional transport, but it should be a transport with specific conditions applicable to it, because the codification is positive. So these are all the elements that we have changed in the TSI. This is complemented by a technical document that will be loaded on our website when the TSIs are published, which is largely based on the USC 5596-6 and a specific application guide on the codification of combined transport that will be also uploaded on our website when the TSIs are published. So that's all I wanted to say very briefly about the codification of combined transport. We believe that many actors will be impacted by these changes from the infrastructure side, from the railway undertaking side, and also wagon manufacturers. So that's why we wanted to make this presentation to introduce the topic for all these actors. Thank you very much.
Hello, good morning to everyone. So following the presentation of Antoine, I will dedicate a bit of time together with my colleagues in relation to the infrastructure and energy TSIs. So in the past revision, we have made some amendments to the infrastructure and energy TSI. Some of these amendments also impacted rolling stock TSIs because we dedicated mostly to interfaces. We have selected today to speak about some specific subjects, as we could not speak about everything. Later on, my colleagues in charge of infrastructure and energy, they will also dedicate a bit of time to what we thought as more interesting to be explained and shown today. So in my case, I will dedicate a bit of time now to speak about the implementation of the TSIs for the existing subsystems. So this is common to both TSIs, both infrastructure and energy, with some slight details depending on the subsystem we are speaking about. So one of our main objectives at this revision was to using the upgrading events in infrastructure and our energy existing subsystems as an opportunity to streamline a TSI compliant fixed installation, being in a more effective way. So we implemented a policy together with the European Commission in order to make the upgrading as an event that pushes the implementation of the TSI. So what we had already in the past, but today they are considered as upgrading and not as a placing into service of a new infrastructure in both TSIs is the examples expressed here in this slide, the realignment of part of an existing route, the creation of a bypass, and the addition of one or more tracks to an existing route, regardless the distance between the original tracks and the additional tracks. The big change in relation to this was the introduction of, I would not call it a definition, but the implementation of a definition of upgrading for both subsystems. So in case of infrastructure subsystem, upgrading as it is described in the Interoperability Directive is a major modification work. Now, implementing this major modification work into the infrastructure subsystem, it was added that is a major modification work resulting in at least compliance with one additional traffic code or a change in the declared combination of traffic codes. So when the applicant, when the infra manager is making an event, is making a project that results in one of these conditions, then we are in the event of upgrading. Now, for the energy subsystem, Cyril, please, next. Thank you very much. Performance criteria that expresses what is an upgrade event also is a major modification work. As this is the let's say the general definition as in the interoperability directive, but for the case of energy is a major modification work resulting in an increase of the line speed of more than 30 kilometers per hour. So for the upgrading existing subsystems, the application of TSI shall be compulsory and apply to the upgraded subsystem within the geographical coverage of the upgrading. So there is a geographical coverage selected by the applicant, and as long as the existing subsystem suffers, between commas, of course, an event of upgrading, the application of the TSI is compulsory. Of course, it was very discussed among the sector together with us that in specific circumstances, the application of the TSI to specific basic parameters may not be so easy and so fast forward. Therefore, in the same chapter of the TSI, which is the chapter dedicated to the implementation of the TSI, the chapter 7, for the case of infrastructure, we have some flexibility in specific basic parameters. All this is described there. Of course, that today we cannot enter into such level of detail, but the audience, after the publication of the TSI, they can see what I am, or they can confirm, you can confirm what I am speaking about. Now, for the other events, then upgrading in particular in the event of a change, the TSI was also updated, and it is also making reference to an existing regulation, which is the implementing regulation 2019-250. And in such cases, when there is a change, the provisions defined in Article 6 and 7 of this regulation shall apply. So basically, what we have done in relation to the adaptation of the fixed installations TSIs to these provisions is that when there is a change, this change is analyzed by the applicant, and depending on the impact of it, meaning the basic parameters that are impacted by this change, then the TSI shall be applied in accordance with what is defined in the Article 6 and 7 of this Regulation 250. And that's all in relation to the implementation of the TSIs. Of course, this was a very summarized description and presentation, also to not fulfill the audience with a lot of this, let's say, implementation issue. And I will then pass the word to Gaetano Imperato. He will speak about the TSI categories of line. Thank you very much.
Hello, everybody. Thanks, Pedro, for the presentation and the kind introduction. As you were saying, I will focus on a specific aspect that we have treated with this revision, in particular the categorization of lines, and cover two main aspects: TSI categories of line and open points, and the Appendix C, where we have closed the open point. As you can see in the screen and also in my background, I put a bridge just to remind that one of the critical aspects was how to classify bridges, existing bridges, and we'll see a bit in details. First of all, first that I forget, I would like really to thank the experts that have worked with us for these 3 years and help us, as you can see in these slides, to clarify some aspects. So indeed, we have TSI categories of lines are described in the TSI with table 2 and 3. And they describe the performance parameters for freight and traffic, for passenger and for freight traffic. We have not changed anything in terms of content, but as we can, but we have underlined in the tables once more that these tables must not be used for route compatibility checks. These route compatibility checks need to be performed following the Appendix D1 in the OPTSI. If we go in the next slides, I will just focus a bit on the changes that we have introduced in the table 2 for passenger traffic, where the dynamic effects need to be considered, in particular for bridges. So we have explicitly insert in the tables for the axle load 70 tons where checks are needed for bridges for dynamics purpose, while for P1 code you can use 21.5 when you need to check the infrastructure. This is really, we will see also in other points, we will continue to make this distinction that was not done properly in the previous one, the previous text. So, but just to assure that nothing has changed, so it's just clarification as given, and you can see there are also notes that explain in details. The same apply for P2, because also there we have these dynamics that need to be considered, so we have different tones. So if we can go to the next slides. Yes, we will enter, we will focus on the Appendix C, where indeed we have closed some open points. To do that, we have distinguished also in these tables that, sorry, I will not display all, I will just make an example in the next one, but we have separated the load capability requirement for bridges from the load capability requirement for geotechnical structures, including earthworks. The same is for passenger and for freight traffic. Another change that has been introduced in these tables is a simplification. We have now not more 3 columns, but we have 2 columns to distinguish traffic with low-haul trains and traffic with electric or diesel multiple units, power units, and rail cars. If we go to the next slides, I think is my last one. Yes, this is where we, this is an abstract of the tables 38 that deal with load capability requirement for bridges, where additional requirements due to dynamic effect need to be considered in case of passengers. As you can see in the last column for P1, but also for P2, we have found an agreement with experts to classify this type of bridges with HSLM that cover is a high-speed load model, covers the dynamic effects, plus inline categories and speed in this one possibility. On the other, we have also found another agreement, HSLM plus LM71 and a certain percentage. This is needed to cover static base load requirements. I don't know if I mentioned, but I will insist here, this Appendix C is for existing structure. This is where is, because this classification is following for new structures with Eurocode. So, but there is always a but. Also, HSLM doesn't cover always all the cases, so due to new trains or due to old bridges. So we have also in the Appendix D1 of OpenTSI the possibility, we have given the possibility to the infrastructure manager to describe the procedures that need to be followed for the classification. This is applied for P1 and P2, but the expert also found relevant to indicate, give this possibility in the note 9 for P3A, P3B, in NP4 that is not displayed. Sorry for that, but we need to keep it simple. And so this is just I'm arriving to the conclusion is a bit of work has been done, but still we need to proceed with the research activities that are ongoing, and we are committed also with a standardization group called DBRIST that are dealing where we have experts of bridges and rolling stock to find a standardized way to proceed for this particular situation. I think I can conclude with this, and just thanks again for the work done until now.
Good morning, dear participants in this webinar. Well, after the kind presentations from my colleagues Pedro and Gaetano on the implementation of the TSIs and the infrastructure TSI, it's my turn now to speak about the evolutions in the TSI for energy, and also, in addition, for the TSI in locomotives and passengers. I'm not going to talk about everything today because I would need the full day. So I will concentrate in the two most important aspects, maybe, that we developed in the NTSI. The first one is facilitate the charging of traction batteries, and the second one, the harmonization of requirements in case of multiple pantograph operation. So let's go for the first one. In this case, the first one, the first topic, ERA members of the topical working group developed important tasks in order to facilitate the use of the battery trains. The interest of the sector was really clamorous. So I need to, firstly to explain the problem we face in this point. In section 4 to 5 of NTSI for current and the standstill, there is a reference to the standard 5367, which limits the maximum current at the standstill for vehicles. A standstill is the situation when the train is stopped, not in movement. With the pantograph could be raised and in contact with the OCL. This section 4 to 5 of the NTSI also corresponds to the section 4 to 8 to 5 of LOC&PAS TSI. You can read in the slides the exact requirement that this OCL shall be designed to sustain at least the values of current at a standstill per pantograph in accordance with the specifications referenced in Appendix E Index 2, which is the standard 5367. In this way, the purpose of this requirement is to avoid the overheating of the OCL contact wire and the pantograph. However, we realize that it has a negative impact in the charging capacity of battery trains, increasing the time needed for charging the batteries. So, next slide, please. Then, in order to solve it, the current limit at the standstill is set up now by updated reference to the standard 5367 in the version 2022. This was updated in both sections of the NTSI and LOC&PAS TSI I referred before, but in parallel, we developed a more important task. That this was the section 42825 of TSI LOC&PAS was amended. You can read in the slide the exact amendment. The maximum current per pantograph at vehicle standstill for DC systems can be exceeded only for charging electric energy storage for traction in allowed locations and under the specific conditions defined in the Register of Infrastructure. And only in that case, it shall be possible for a unit to enable the capacity to exceed the maximum current at the standstill. In other words, it is allowed to overpass the such limits for trains equipped for electric energy storage for traction purpose, which means mainly battery trains. This permission is based in the fact that in some infrastructure managers allow higher values of current at standstill than the ones in the standard 5367 and in certain points of their infrastructure. And these values have to be registered in the Register of Infrastructure. And in these cases, the battery trains can require a higher value of the current, reducing the time for charging the battery and enabling better performance and operation of these trains. So it was an important development in the TSI. But of course, we are in a kind of a front line of research for these battery trains. And we need to continue forward in the next TSI revision to have interoperable rules and solutions for the network. This could require additional information for the technical solutions at the pantograph and the contact line, and also for operation and signaling of such charging sections, having an impact in other TSIs as well. Then next slide. Then I finished with the first point. So let's jump to the second one, that is multiple pantograph operation. What does it mean? It means operation of a train with more than 2 pantographs working simultaneously. It is the interest of the sector to enable better performance and operation of electrical trains by using more than 2 pantographs at the same time. However, the operation of more than 2 pantographs is subject to different rules and practices in the member states and in Europe. And this does not facilitate the authorization and operation of trains with this specific configuration. Then, ERA and the sector perform a research on the possibilities to harmonize the requirements at the European level, which means mainly the Energy TSI and the LOC&PAS TSI. So, next slide. Okay, in this point, I need to explain which were the working lines developed during this task. And the first one, it was the analysis of the local rules for this kind of operations in different member states. This was the first step to do. This could, in order not to be many details, but this implied or this required the compilation of rules for multi-pantograph authorization in Europe, the identification of differences between different types of units, locomotives, DMUs, and the systematic compilation of results from the assessment for multi-pantograph operations in Europe. So the state of the art, let's say. We also, and the sector in the working party, we also proceed with the analysis of the different types of measurements and simulations and the related possible impacted parameters. Some parameters were confirmed, but not all influences were identified. And I mean, say, positive results were obtained for more than 2 pantographs, plus only up to 160 kilometers per hour. And in parallel of these two previous actions, the TSI was checked in order to detect the possible improvements and adjustments, taking into account the results of these measurements and simulations. Next slide, please. At the end, it was concluded that more measurement simulations are necessary. For instance, more pantograph instances to be simulated and measured. And we need to finally identify all the parameters. Few were identified, but not all. In order later to develop a method for the assessment of the OCL and the pantograph, and later on, finally, to have stable proposals for TSI's amendments and eventually the development or modification of EN standards. At the end of the project, it was also defined the future research steps for the use of multiple operation of pantographs. I need to say that it means that additional future research program outside the ERA TSI work may be possible forward, but it's out of the TSI work. We need to have this in mind. So for this research, we need to maybe explain some possible actions, like the definition of critical distances between pantographs for the maximum speed, the defined rules for the range of the best pantographs for position configurations, rules for a robust contact line design, rules for the allocation design, and rules for positioning of pantographs on the train. Also, simulations to investigate the influence of parameter changes. Different actions were defined in order to develop this future research. Of course, even if it's out of the TSI scope, because TSI is regulation, ERA is involved and with the sector in this would be involved in these future research projects. And at the end, at least we had some amendments in the ENE TSI and the LOC&PAS TSI. At least we identified some improvements. In the energy TSI, in the sections 4 to 12 and 4 to 13, we updated the references and the pertinent references to the standards 50119 and 50367. And in LOC&PAS, important, in section 428 297, we included clarifications on dynamic behavior. And in 62321, we included provisions to test at least the poorest performance configuration of pantographs. That was at least achieved in the TSI. But of course, we are ready to continue with the work to incorporate future research projects in the next ENE TSI revision. So I think I finished in this way. I hope not, and I didn't extend too much. And I leave the floor to my colleague, Roberto.
I'm most probably the last one presenting some content today. So thanks for your patience. And once again, good morning to all of the attendees today. So I will speak to you about the TSI OP 2023 as revised. Of course, the TSI 2023, all TSIs 2023 are not yet published. They are going to be published soon. And today we focus also on the topic of the communication information exchange between the infrastructure manager and DRU. So based on the text as voted during the last risk meeting in March, the relevant, let's say, TSI OP requirements are the ones defined in the 421 information exchange between IAM and DRUs, and the 421 for informing the driver in real time during train operation. The topic of this information exchange can be summarized by the table you can see here in the slide. And so you can see that three main level, let's call it like that, of communication have been identified within the two requirements of the TSI OP I mentioned before. So on the left, you can see what can be called as normal communication. So basically here is the communication is between infrastructure manager and railway undertaking, meanings between organization, not people. Example of such type of communication are, for instance, the communication between IAM and DRU with the relevant parameters for the route book, such as, for instance, information about the line, signal, station, planned works on the infrastructure, planned speed limitation. But here the main concept is that the railway undertaking has enough time to digest the information given by the infrastructure manager, meaning that, for instance, if there is the need, he has enough time also to train the driver and so on and so on. So to integrate the new information within its own organization. And to, I mean, the means of communication for those type of communication are exclusively the RINF application as defined by the TSI OP. On the opposite side, so on the right side of the table, you can see that we have this emergency communication. So of course, this refers to an emergency situation that needs to be dealt as soon as possible. Maybe this situation is already foreseen by the safety management system of both the infrastructure manager and the railway undertaking, but in that case, the communication should be as fast as possible. So the communication is not between organization, but between people, the signaler and the driver, by using any available means as fast as possible. In the middle, in the middle, we have identified two different situations. One is as for the normal communication, but there is not enough time given to the railway undertaking to digest such an information. As an example, it could be an information about a speed limitation just a couple of days before the entering into force, or an unplanned work on the infrastructure. So the concept is that the railway undertaking had not enough time or have not enough time to digest such an information, and therefore there is the need for giving also real time, every day, every train departure, the same information also to the driver. In that case, there should be two different means of communication: RINF between organization, infrastructure manager and railway undertaking, the same process as for the normal communication. And then a direct communication between the signaler and the driver by using operational instruction. And this second case of communication between the signaler and the driver can be used also, for instance, for the integrated operations. So the graded operation is something that is managed within the operational instruction of both the infrastructure manager and the railway undertaking, but it's something that cannot be planned. And therefore, there is this real-time communication. In that case, the communication is directly between the signaler and the driver, and they will use the operational instruction as means of communication. Of course, the TSIOP does not define the timing for having the information given via RINF or via operational instruction. Therefore, the IM and the RU should collaborate in defining an operational procedure to manage the communication, each one with its own risk assessment. This means that the communication as defined in the TSIOP should be integrated into the SMS of both the infrastructure manager and railway undertakings involved. I think that's it for the presentation. And so I put back the floor to Cyril. Thank you, everybody.
Thank you very much, Roberto, and thank you very much to all my colleagues. We will now move on to the Q&A session of this webinar. So the first question is for you, Gaetano. In case of P3A, why the speed of 100 km/h is lower than the speed range for P3, 120 and 200? Gaetano.
Thank you, Cyril. This is a very detailed question, but allow me to, I don't know if we can go to the slides again. No. So indeed, it was in the last slides I presented, there was for P3, we mentioned that the load length that is a specific characteristic of the bridges. So it depends on how, if it's more or less than 4 meters, and this allowed to have different speed indication. This is to be noted that this, I think I saw also in the chat another one that I can answer directly, is this speed does not be to be considered the permissible speed for the vehicles, but is really speed used for the dynamic enhancement factor when we are calculating these bridges. I hope this help. So, Cyril.
Thank you, Gaetano. The next question is for you, Pedro. Did the ERA define a time frame for the classification of existing railway bridges? Pedro.
Thank you very much, Cyril. Indeed, this classification, so the addressing of traffic codes to the infrastructure subsystem, being a bridge, being straight line, is nowadays already requested under the RINF decision. So let's say that the RINF needs to be populated with such data, meaning with the line classification and the structure classification if the bridge is referring to an operational point, and there are specific parameters where this classification shall be done. Of course, RINF is not exactly what we are discussing here today, but I can provide this reply. Also, it's quite important at the level of the let's say, the strategy and the implementation of the TSI for future events, like as we have explained, or I have explained a bit before. These traffic codes also will assign the change of them towards a specific target system. Will also provide, let me be a bit redundant in the word, but the classification if the event is an upgrading event or a modification under the regulation 250, as explained before, and therefore this classification is expected to be already in the data which was serving to populate RINF. Thank you very much.
Thank you very much, Pedro. Next question is for Esteban. Esteban, it's about the TSI energy. In point 4.2.18, there is no more a reference to point 6.1 and 6.2. This must truly be a mistake, our attendee asks. Or can it be that there is a deliberate decision that earthing and bonding on non-public areas is no longer TSI requirements? Esteban.
Yes, thank you for this question. Yes, it's true. During the discussions in the working party, the elements 6.1 and 6.2 were deleted as a reference because it was considered that in this point, this was already covered by the new version of the standard. So it was not necessary to refer to this TSI requirements. And also, in this case, the provisions were considered by the experts of the working party more an indication than requirements. So in order to simplify the references in the section 4.2.18 of the TSI energy, when updating to the new version of the 51.2/1, these points were eliminated. Thank you. I hope that this answered the question. Thank you.
Thank you very much, Esteban. Back to you, Pedro. We have another question for you. You mentioned at the beginning that other elements were developed for the TSI energy and infrastructure TSI. What are they?
It's not a complex question, Cyril, but it is a big question. So before I will try to list the main points, but once again, it's very difficult to me to be sure that I am being exhaustive in this description. So each time we do a revision in the TSIs and the packages like this, the sector and us, we always use the opportunity to often extend a bit the mandate provided by the Commission, and meaning we always do some other amendments. We use the opportunity to introduce some changes and to correct some deficiencies and a lot of things. But in any case, I will try to be a bit more descriptive. So as Antoine already has shown in the first presentation of today, in the TSI infrastructure, we have included the references to the combined transport. We had also updated the standards in the TSI, meaning that as long as possible, references to the new versions of the standards are also taken into account in this revision. So Gaetano spoke before about the traffic loads. I've spoken on the upgrading and renewal of existing subsystems. There were changes like, for instance, equivalent vertical loading for new geotechnical structures, earthworks, and earth pressure effects, as also linked with Gaetano's presentation. We have also introduced a new standard for the maximum pressure variation in tunnels. There were changes in the design track gauge for track sleepers, assessment of track layout, water restocking, where we made reference to the new directive on the quality of water, changes in Appendix C2 on the update of the technical characteristics of switches and crossings, assessment of maintenance file, platform 8. So we did perform some other changes that they can be checked then in detail, both in the recommendation that it is available in our website, and you will be also be able to have this full, let's say, list of changes. I would not like to say it this way, but the implementation of these amendments when the TSI will be published. For instance, in the TSI Energy as well as in the TSI Infrastructure, we did also a huge update on the standards. Then there were aspects like, as Esteban already presented, the exceedance, the permitted exceedance of limit for the current at standstill, for these cases of battery charging. Also in the section 428, harmonics and dynamic effects, Appendix D. Also some adjustments in the dynamic behavior and the quality of current collection provisions in the TSI Energy, requirements for the design of OCL for multiple pantographs. It was explained by Esteban as well what was done, and I was trying to figure out what it came more to my mind, the deletion of performance parameters in section 421. This needs to be noted that these amendments, part of them were decided in previous working parties, but unfortunately we had no opportunity at that time to make the changes. So we used also this revision to make these changes. So amendment of the assessment procedures in section 624.1, modification of the parameters, voltage and frequencies, and so on and so forth. So I think I was even not being exhaustive, but quite descriptive in the major changes performed. Thank you very much, Syria.
Well, thank you, Pedro, for this very detailed answer. I now have a very long question for you, Antoine. The adoption of the special transport regime to move any standard container is a fundamental obstacle against combined rail transport, deserving of a solid and structural solution. Considering the margin available between the max gauge of the rolling stock and the actual minimum physical gauge of the railway lines, narrower tunnels, do you think it is feasible to modify the TSI infrastructure to make room for the upper corners of the containers mounted on railway wagons, leaving this space free from other line infrastructures such as cable ducts, pipes, etc., possibly providing for their displacement? Antoine, the floor is yours.
Thank you, Cyril, for this. Thank you.
We have a slight technical problem. Can you close and open your camera, please? Apologies. We'll try to show Antoine. Antoine is back.
Thank you. Okay, thank you, Cyril. Can you repeat the question? I forgot. Okay. So what I said at the beginning, with combined transport, the reference profile of the gauge is exceeded. But beyond the reference profile, there are some tolerances, there are some extra taken, either defined by the standard or taken by the infrastructure manager, meaning that the location of obstacle is beyond also the reference profile. So there is some free space which is used in particular for the exceptional transport. What we have defined in this revision of the TSI basically is another virtual line, which is the combined transport profile of the line. But we have not defined how to determine the combined transport profile of the line. We leave this to each infrastructure manager. It can be done either by referencing to the standards. In that case, the combined transport line profile will be more or less equivalent to the reference profile defined for the gauge, or it can be also defined differently, either by reducing the allowances or by making measurements on the field and determining the exact location of the obstacles. So to make changes in the infrastructure TSI to define how to determine the new profile, the combined transport profile, is certainly something that would be beneficial. Unfortunately, for this revision, it was not possible to do it because there is absolutely no harmonization on that. There are, I think, some research projects ongoing, in particular managed by UIC. There may be also some standardization activities on the topic. So in a future revision, we may think about some harmonization in the determination of the line profile, but at the moment, it remains the responsibility of each infrastructure manager to determine how they will determine this line profile, combined transport line profile. Thank you.
Thank you very much, Antoine. Next question is for you, Gaetano. Why are there still open points for the traffic code P1520 and P1600?
Thanks. Thanks, Cyril, for this question, because it can complement what I was said, but still work need to be done also for the Appendix C. So indeed, these traffic codes are used for North Europe countries, so Baltic states and Ireland, and we didn't have experts. So this is give me the opportunity, open call for experts to join our activities, and so we can advance also on these topics.
Thank you very much. Esteban, next one is for you. How to consider another pantograph designed only for charging ESS, but with another shape than defined in EN 50367?
Yes, thank you for this question. This is interesting because you mentioned the standard 5367. I mean, the standard contains many conditions, also for certain shapes of pantographs, but we have to consider that the mandatory part of the standard is that the one referred in the TSI, which we consider is the section 7.2 and the table 5. This is the really mandatory part through the reference in the TSI. And in the standard, the table 5 establishes some limits for AC and DC systems. And for DC systems, these limits, 300 amperes and 200 amperes, need to be repeated and need to be fulfilled. So this is mandatory, whatever is the situation for the pantograph. So these requirements are fully applicable for all pantographs willing to operate in a train in a standstill situation. So that it will be mandatory for these pantographs as well. I think this is answering the question in short words. Thank you very much.
Thank you very much, Esteban. I have now a question for Roberto. Roberto, for clarification regarding communication between infrastructure manager and railway undertaking, can you confirm that the real-time communication header does not imply that RINF needs to be used real-time? It means that on top of the normal communication process, the operational instructions also need to be used for the restriction available only shortly before the train is running. Roberto.
Yeah, thank you, Cyril. On this, I can confirm that the new text of the TSI-OP refers to a communication methodology established between IM and RUs in line with the Appendix C. So with the informing the driver in real time during operation, today is left to the SMS of the IM and the RU. There is no means being imposed by the TSI-OP to define such type of real-time communication. There is a reference to the Appendix C, that is the appendix dedicated to the communication procedure, let's say like that, in the TSI-OP. I hope this answers the question. Thank you.
Thank you very much, Roberto. Thank you very much. And I think, dear attendees, dear speakers, all good things must come to an end. We really hope that you enjoyed this webinar and that it fulfilled your expectations. Thanks for attending this event. It's such large numbers. Last word that my colleagues asked me to tell you, yes, that ERA is not entitled to make any interpretation of the law. We just provide some help, right? Yes, that's important. Thank you very much, my dear colleagues, for your work and dedication in preparing for this webinar. Thank you, dear attendees, for your interest in these webinars. These two webinars on TSIs have set absolute audience records, unmatched since we started organizing them. So thank you very much for your trust. Before you go, we would be very happy to receive your feedback on this webinar via the QR code you're seeing right now on the screen. We look forward to meeting you again. Maybe it could be at the upcoming European Rail Safety Days that will take place in Tallinn, Estonia in September. Registration for this event are open. If you're interested, please visit the agency's website and register. We would be very happy to meet you there in person. The detailed agenda with the speakers, the topics of their speeches, and the workshops details are available on the website. Also, you can already note that a follow-up webinar of these safety days will be organized on the 13th of October. Having said that, if you would like to stay updated on our activities, please sign into our database by selecting the button Login on our website page. And you can, of course, follow us whenever you want on our social media accounts, Twitter and LinkedIn. Take care. Bye.